Hello everyone, I'm Michael, and today we're going to talk about the rule of 72. More specifically, I'm going to explain the math principle behind why this trick works. So what is the rule of 72? Well, it is a math shortcut you can use in finance, which gives you the number of years it requires for your investment to double in value, given the annual rate of return. So, for example, if my annual rate of return is 3%, and I want to know how many years it would take for my investment to double in value, then I will use 72 and divided by 3, it's equal to 24. So approximately it takes 24 years for my investment to double if the annual rate of return is 3%. So let us check the calculator. 1.03 to the power of 24. And it's equal to 1.03 to the power of 22. It's equal to 2.03. So it's off by what? 1.5%. So you see, this trick is only an approximation, but it's pretty precise, and it's convenient when you don't have a calculator. And we can use another example. If the annual rate of return is, let's say, 9%, and I want to know the years it takes for my investment to double in value, I use 72 and divided by 9 is equal to 8. So it approximately takes 8 years. Let's check the calculator again. 1.09 to the power of 8. It's equal to 1.99. So off by what? 0.5%. You see, it's incredibly accurate. It also works the other way around. Let's say your kids go to college in 12 years, and you want your investment to double by then. So you want to know what annual rate of return would enable you to double your investment in 12 years. And you will take 72 and divide it by 12. It is equals to 6. And let's check the calculator. 1.06 to the power of 12. It's equal to 2.01. So it's off by 0.5%. And now let's figure out why this math trick works. If you want to figure it out yourself, you can pause the video here. So let's say our annual rate of return is R%. That's a horrible R. And it will take n years for my value to double. So we can write the equation as 1 times 1 plus R% to the power of n equals 2. So I initially have the value 1. It takes n years for my value to become 2. And a natural approach here would be to take the natural log of both sides of the equation. Y base e, you can also use other base. It's completely up to you. It's just the convention to use the natural log. And now we can use the power rule of logarithms to pull n as the coefficient. Now, we can actually use a very smart approximation, which would simplify this term to R%. I know what you're thinking here, but this actually works. For small values of r, natural log of 1 plus r% approximate to r%. So we can actually check the graph calculator here. You see, for small values of r, I use x here. Like you can see 0.02% here, 0.02. So it will correspond to 2% in our case. And the two graphs nearly overlap each other. They are very close together. So it's a good approximation. And using this simplification, we can reduce our equation to this. Now we will times 100 to both sides of the equation to remove the percentage sign. And now you can see we've already arrived at a pretty neat equation. We simply need to figure out the value of 100 times the natural log of 2. Let's check the calculator. 100 times the natural log of 2. And the value is around 69.3. So now you are probably thinking, why not use 69.3? Why did you use 72? Well, 72 is the multiple of a lot of integers. It includes 1, 2, 3, 4, 6, 9, 12, 18, 36, and 72. Oh, I missed 24, but never mind. So basically a lot, the multiple of a lot of integers. Therefore, it would be easier to divide 72 by a number. And that is how we arrive at this math trick. So if you're interested, we can actually plot this equation, which is a hyperbola, on the graph. So x times y is roughly equals to 72. So for every point on this graph, the x value corresponds to our value of r. So for 5, it means that your interest is going to be 5%, and it will approximately take 14 years for your value to double. Yeah, it's pretty much all of the content here. Thank you for listening, and I'll see you next time.